Hi everyone, welcome back to the channel. I'm the GCSE science teacher. I hope you're doing well. Today is actually Christmas Eve as I'm filming this. I hope you're having a fantastic holiday if you are a student or if you are someone who's just found this video and you're interested in moles. I hope you're having a great time as well. Essentially, this video is going to help you with moles. It's a topic that is for higher combined triple and other students who are doing GCSE chemistry. If you do find the video helpful, feel free to join our community and subscribe. Thank you so much if you've already subscribed, by the way. I really appreciate your support here on my channel. I have an Instagram, I have a TikTok. All of it is at the GCSE Science Teacher. Let's get into it. So, what is a mole? Well, the way I tell my students in real life how to actually remember this is it's just an amount of substance, it's amount of stuff. So if I said to you, hey, can you get me a pair of socks? You would get me 2 socks. If I said to you, can you get me half a dozen eggs? You'd get me 6 eggs. It's the same for a mole. A mole is the amount of something. And because we know that atoms are so small, we have to use this number, this amount of something called a mole, to actually utilize the number. We can't go off one atom because it's just too small. So we have a collection of atoms that we call a mole and we quantify it in that way. Um, One thing you can do in your GCSE exams is to know the relative atomic mass and relative formula mass. I did a video previously about this, I'll link it for you. But a mole is the relative atomic mass of an element in grams or the relative formula mass in grams of a compound. So if we have, for example, a molecule of water, the mole of water is 18 grams because we've essentially done the number of the relative atomic mass of hydrogen, which is 1, and there's 2 hydrogen atoms, so we've times it by 2, which we get 2, and then oxygen, the relative atomic mass of oxygen is 16. So 16 plus 2 is 18. So a mole of water is 18 grams. A mole of other substances will just essentially be the relative formula mass or the MR. Now, I've used some examples in my previous video to show you this. A mass of 1 mole of substance in the second example is 138 grams. The third one is 74 grams, that kind of thing. So you can see that a mole is very much linked to how much mass there is in terms of the atoms as well. So we now go into this idea of Avogadro's constant. Now, Avogadro was a scientist, a chemist who kind of came up with this idea. So because the atoms and molecules are so small, the number of atoms in a mole is very large. The number of atoms or ions or molecules or particles in a mole of substance is called Avogadro's constant. So this is how many atoms there are in 1 mole of substance. So there's actually 6.022 times 10 to the 23, or this massive number you see in front of you. That's the number of atoms in 1 mole of substance. And 1 mole essentially is equal to the number of particles in 12 grams of carbon 12. Carbon is used as kind of a unit of comparison in this way. So when I say to you a pair of socks, I mean 2. A mole of something is this Avogadro's constant in terms of the amount of particles or atoms there are in 1 mole of substance. Okay, so in the exam, you could get asked to calculate the number of particles in a substance. So if we know the Avogadro's constant, we can work out how many moles there are. So calculate the number of water molecules in 1 mole of water. We would just do the Avogadro's constant, 6.022 times 10 to the 23, and we would times this by 1 because we just have 1 mole of this substance. So we'd still get the answer of 6.022 times 10 to the 23. Now, if we wanted to know how many atoms there were, we would actually see that there are 3 atoms in 1 molecule of water. Remember, we've got 2 hydrogens and 1 oxygen. So we would just times this number that we've calculated by 3, and we'd end up with an answer of 1.806 times 10 to the 24. And that is how we work out the number of atoms in that molecule. Now, here are some other examples for you to have a go at. Feel free to pause the video, comment down below any of your answers, any of your working out. If you are enjoying the video, feel free to like and subscribe, and I will show you after you've paused it, you'll see the answers on the screen as well. Okay, so hopefully you had a go at that and you've had a chance to look through your answers, that sort of thing. These are the answers on the screen for you. You can see that in the first one, I'll go through that one. It says calculate the number of oxygen atoms in 0.25 moles of oxygen molecules. So we needed to work out the number of oxygen atoms at first. So we do 0.25 times the Avogadro's constant, and then we're timesing it by 2. And the reason we times it by 2 is because oxygen is a diatomic molecule. O2 is a formula for oxygen, and that's why we get an answer of 3.01 times 10 to the 23 oxygen molecules or atoms, I should say. I hope you did find those quick checking of understanding questions helpful. Comment down below if you like this format, if you like some questions to pause it and then have a go yourself and get the answers. It's always good to practice. Let me know if you are enjoying that. So that is just a whistle stop tour of moles. If you did find the video helpful, feel free to subscribe. Thank you so much for your time. I'm looking forward to creating some more quantitative chemistry videos, especially as we move into titrations and concentrations and things like that, and reacting masses. I know a lot of students over the years have always benefited from going through step by step and have DM'd me on Instagram about going through that as well, making a video. So I will be making that very, very soon. Have a fantastic day. Thank you so much. I've been the GCSE science teacher and you have been curious. I'll catch you in the next one. Take care. Bye.